Okay, so if you're watching this video, that means I'm home with a sick kid today. So I hope that you guys had a good chance of working through finding your zeros using the remainder theorem. Remember, find all the factors of the constant divided by all the factors of the leading term coefficient. So let's look at a couple of quick examples from your homework. From 6, let's just start with, let's see, we started at 40, so let's start with 42. So when we look at number 42, I'm going to list out all the factors of 12. All the factors of 12 divided by all the factors of 1. So it's plus minus 1, plus minus 2, plus minus 3, plus 4, plus minus 6, and plus minus 12. From that, you use your synthetic division to find your zeros. Pull your coefficients out. 1, negative 3, 6, negative 2, negative 12, and just start at the top. Didn't work. Try negative 1, negative 3, 6, negative 2, negative 12. Worked. Negative 1 worked. Circle it. Now remember, that means as of right now, I have a term, x plus 1 times the quantity, x cubed minus 4x squared plus 10x minus 12. When I look at that cubed function, a lot of times when there's 4 terms here, I look to see if is it possible to group here. Unfortunately, I'm not going to be able to group this one. So again, I just continue on with my synthetic division with this set now. Look again, we happen to wind up with the same factor of constant. So we start at the beginning, in case there's a duplicate. 1, negative 4, 10, negative 12. Start at 1 again. Nope, try negative 1. 1, negative 4, 10, negative 12. Nope. Go to 2. 1, negative 4, 10, negative 12. Excuse me. And we got to another one. So we now know that it is x plus 1, x minus 2. Since my 0 is positive 2, my term is x minus 2. And I'm left with x squared minus 2x plus 6. Can you multiply two things together and get a positive 6 and wind up with a negative 2? Well, in this case, I can't think of something off top. I can't think of anything off the top of my head, which means we're going to check to see if we have an imaginary solution. Remember, in section 6.6, they're just looking for real zeros. As of right now, we have real zeros at negative 1 and at positive 2. So check with the quadratic. Look at the discriminant. If I check the discriminant, remember, I'm looking for the b squared minus 4ac. So 4 minus 4 times 1 times 6 is going to give me a negative 22. Since that's the discriminant, that tells me that I have 2 imaginary solutions, which means I'm done for this problem. My zeros are at negative 1 and positive 2. Okay? That's what 42 looks like. If we scroll through and we look at 44, I'm sure most of you guys looked at that and went, oh no, I can't do it. Yes, you can. Again, you have your zeros, or check your possible zeros for 12, divide them out by 1. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Start with your 1 and work your way through your synthetic. 1, negative 7, 11, negative 8, and 12. And that didn't work. Continue on with the next one. Try -1. 1, -1, -7, 11, -8, 12. And that won't work. Go to 2. And we have a winner. I have a 0 at +2. I circle it. Now I know that my term is x minus 2, and it's times, we started with the 5th degree, now we have 4th degree at x to the 4th plus x to the 3rd minus 5x squared plus x minus 6. Now, in this instance, I don't need to worry about, I can't group it, I can't do anything else, so I'm just kind of trying to figure out where else I can go from here. I continue on with my synthetic division. I'm going to back out that 0 here and start here. Now, my new one starts at 6. So we can go through again with the 1s. So what I'm saying here is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We don't have to worry about the 12 at this point, so I'm just going to cutting it down. -3, -3, -2, -2. No more. Try with -1. -1, -1, 0, 0, -5, 5, 6, -6. Ooh. Check my signs, make sure I didn't screw up. Nope, didn't work. Try 2 again. And I know right about now you guys are going, oh, can't I use my calculator? Remember, calculator, non-calculator. This would probably be a skill that you have to know how to do without a calculator. Plus, that's what's going to happen when you guys get to pre-calc. You have to be able to do some of this stuff without calculator. Again, I have found that I have a 0 at 2. So remember, our term was up here. The 2 just happened to be repeated. So you have x minus 2, x minus 2, and now what we're left with is x cubed plus 3x squared plus x plus 3. There's 4 terms right there. I should be able to factor that by grouping. Group them here, and then group them here. Take out the x squared, I have x plus 3. Take out a +1, and I have an x plus 3, which leaves me x minus 2, x minus 2, x squared plus 1, and x plus 3. Remember, we are trying to solve for the zeros. I know that I have a 0 at 2, another 0 at 2. This is for real zeros in section 6.6. So this one will give me an imaginary answer. I'm not worried about it. So my other 0 is at -3. In section 6.7, you would find this at plus or minus I when you, you get I there when you subtract out, you get the square root of -1. So we'll worry about this stuff more in a couple minutes. The rest of 6.6 should have flowed rather quickly. As you get into the 48 through 58, the sections in here, pointing, you can't see me pointing. What happens a lot of times is that, for example, in number, what was it? 50. A lot of times, these wind up being trick questions. And if you look at it, you have 4 terms, and you could probably get GCFs. You don't need to always use synthetic. Use the skills that you know how to factor. Take out the x squared, you get 2x plus 1. Take out a -25, you have a 2x plus 1. X squared minus 25, 2x plus 1. Your zeros are at plus or minus 5, and -1/2. You can do that. You don't necessarily need to use synthetic. Think about all the different possible ways of factoring. So for the rest of these answers that you're looking for, remember, help yourselves, look at the big book of answers on the desk. You can check out your rest of your answers. But I'm going to skip ahead and start looking at 6.7. In 6.7, I had you guys do two problems, 22 and 24. So let's look at them. What's different between 6.6 and 6.7 is the instructions. It says find all the zeros, which is including anything that's imaginary. Again, factors of 27 divided by the factors of the leading term coefficient. Plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27. So it's really not that bad. Starting with the fourth degree polynomial, all of my exponents work going all the way down. Start with 1. Synthetically divide, we have a 1, 4, negative 6, negative 36, negative 27. I will remind you, watch your signs. No workup. Negative 1. Negative 1, 3, negative 3, negative 9, 9, negative 27, positive 27 is 0. Right here. It works. Negative 1 is a 0. If negative 1 is a 0, I want to write out my terms so you understand how we're factoring this. We have factored out an x plus 1. I am now left with x cubed plus 3x squared minus 9x minus 27. Again, at this point, you should be able to recognize that you could group that. Factor out your GCFs. X squared, you have an x plus 3. Take out a negative 9, you have an x plus 3. Which means your factored form of the whole problem, x plus 1, x squared minus 9, and x plus 3. The instructions were to find all of your possible zeros. Well, you know you had one at negative 1. This one's easy at negative 3. Here you add 9 and take the square root, plus or minus 3. So all of your possible zeros are negative 1, positive 3, negative 3, and negative 3. Tomorrow, we will describe what that means graphically of what's occurring. We'll explain more of it. Today, we're just listing out all of the zeros. So that's 22. 24 is very similar to that. But I hoped in 24 you didn't do any synthetic division, because you don't need to. Again, factor by grouping. It's faster. Recognize it, see it to go. Every time you think about factor by grouping, you look for 4 terms. If you have 4 terms, go for it. Try it. Take out the x squared, you have an x plus 5. Take out a negative 4, you have an x plus 5. X squared minus 4, x plus 5, set them equals 0, plus or minus 2, and a negative 5. That's how that works. Now, what happens in the rest of section 6.7 goes back into when you're working with some imaginary numbers. So let me show you an example of what's possible here. I'm going to look at number 31 in your book. Number 31 in your book starts with a 4th degree polynomial. We don't really know how to factor that straight away, but we do happen to have an easy coefficient to work with. I have a 6 at the end. A 6 here, and a first term coefficient of 1. I'm sorry, I said coefficient, but this is the constant. So you have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. You're going to start checking with your synthetic division. Start with 1, use your coefficients, and just start the process. 1, 1, 0, 0, negative 5, negative 6, negative 6. That didn't work. Try negative 1. 1, negative 1, negative 5, negative 1, negative 6. Make sure I ain't lost my signs. and go to 2. So we have 1, 2, 1, 2, negative 3, negative 6, negative 7, negative 14, and it didn't work. Try negative 2, 1, negative 1, negative 5, negative 1, negative 6, 1, negative 2, negative 3, 6, 1, negative 2, negative 3, 6. There's my 0. If negative 2 is my 0, that means my term is x plus 2. And now that I started with a 4th degree polynomial, I'm now with a 3rd degree, x cubed minus 3x squared plus x minus 3. And once again, you should recognize something that can be factored by grouping. So we have x plus 2. Factor out your x squared, you get an x minus 3. If they have nothing in common, it means they always have a positive 1 in common. Factor it out, you have an x minus 3. Your final answer is x plus 2, x squared plus 1, and x minus 3. We're setting them all equal to 0, which means we have zeros at negative 2, 3, and you have x squared plus 1 is 0. X squared is negative 1. X squared is the square root of negative 1. Oops. X. And remember, what happens when you take a square root over an equal sign? It's plus or minus. So there's your 4 possible solutions. That is how we finish out the other style of factoring given your rational zero stuff. The other last bit of section 6.7 only takes a minute or two to work out. So let me pause this for a second while I set that up, and we'll get right back. Okay, so here's what's going on. Now you're going to be given 1, 2, well, obviously you have to do more than 1, 2, 3, 4, maybe even 5 possible zeros, and you have to figure out what does the polynomial look like, given that those are the zeros. And we've been saying this all along, so the vocabulary here shouldn't come as a shock to you whatsoever. So if I'm looking at number 35, and I have zeros at 2, 1, and 4. If my zeros are at 2, 1, and 4, that means my terms in parentheses for each of these would be x minus 2, x minus 1, and x minus 4. Now, you need to write out what the polynomial looks like. Once again, all we're doing is foiling and distributive property. Foil out, we have x squared minus 4x minus x plus 4. So I have x squared minus 5x plus 4. To that, I'm going to distribute the x minus 2. X cubed minus 5x squared plus 4x minus 2x squared plus 10x and minus 8. Combine your like terms, x cubed minus 7x squared plus 14x and minus 8, and there's your polynomial. Another thing to pay attention is you had 3 zeros. What's the degree of your polynomial? It's 3. It's a very simplistic thing to do. I've been asking you guys all along, whenever you have a 0, what's your term? So if you see on 36, your zeros are 1, negative 4, and 5, which means your terms, x minus 1, x plus 4, and x minus 5. Now, the trick is going to come in, of course, there's always a trick, when you have to deal with imaginary 1. For example, if I give you 3 zeros at 3i, negative 3i, and 5, using the same idea of the parentheses, we know the 5 one. That's easy. The other two are a little bit weird. So what if I just said it was 3? You guys would say it's x minus 3. Since the 0 is 3i, it's x minus 3i. Since the 0 here is negative 3i, it's x plus 3i. Again, all you have to do is FOIL it. So we'll worry about the x minus 5 later. Let's FOIL this. We wind up with x squared plus 3i x minus 3i x minus 9i squared. Your middle terms here drop out. And remember, minus 9 times negative 1 is x squared plus 9 times x minus 5. Lastly, we get x cubed minus 5x squared plus 9x minus 45. And there's your answer. A trick here to remember is whenever you're dealing with a plus and minus I value, if it's plus and minus 4i, that meant your term is always x squared plus whatever this number is squared. Always works. Always works. It's a nice little trick. So what I want you guys to work on tonight is I'm going to give you a couple of more of the factoring problems out of 6, 7 by finding zeros. So let's work on numbers, we left off at 24. So on page 369, this is section 6.7, I'd like you to do numbers 26 through 46, evens. Oh, you know what? Let's stop at 42. And one hint with number 42, if there is a negative 6i, there has to be a positive 6i. So you wind up with 2, negative 2, negative 6i, and 6i. That's a little bit of a trick. The book doesn't do a very good job of explaining that, but we'll go from there. Give those a shot, and we'll see how we do from that. Remember, we're still testing on Tuesday. On Friday, we're going to go over 6.8 and one part of 6.9 and call it a day. So, hope you guys have a good one, and I'll talk to you later.